All right, so this last example, we're using the classical approach, and recall from just our discussion about these two approaches. The first is called the p-value approach. The second was called the classical approach, or the rejection region. Okay, critical region, rejection region. Remember, no matter which one you do, if you were to complete the other approach next, you should get the exact same result. So if you get fail to reject a null, when you do the other approach, you should also get fail to reject a null. Okay, that's why I like them, because they're kind of fail-proof. You know, you can do both and check your own work, which is really nice. If you were to use the confidence interval approach, Miss Whitaker taught it to you last year. I don't talk about that approach, but sometimes you can get different results. I was reading one of the statistics textbooks that I look at, and it just said sometimes you don't get the same result as if you use the p-value approach. It did not explain why. It just said it does sometimes happen. So my theory is, if it sometimes happens and I can't tell you why it happens, I'm just not going to do it. I can tell you for sure if you use either of these two, if you use them and then you use the next one, you'll get the same thing. Unless you have a mistake, which is nice, because then you can go, oh yeah, I forgot to subtract from 1 for my p-value, or I forgot to whatever. You know what I mean? All right, so this one says, it has been claimed that the mean weight, that's important, mean weight, so I'm talking about mu, the mean weight of women students at a college is 54.4 kilograms. Professor Hart does not believe this claim and sets out to show that the mean weight is not 54.4 kilograms. To test the claim, he collects a random sample of 100 weights from among the women students. A sample mean of 53.75 kilograms results. Is this sufficient evidence for Professor Hart to reject the statement? Use alpha equals 0.05 and sigma equals 5.4 kilograms. So the first thing I want to say is it's important to know what your parameter of interest is. The further we go in this class, if you don't know that, you don't know which test to perform, okay? So number one, we're talking about a mean, okay? The next thing is, do you know the population standard deviation? Yes, you do. So because of that, it's a z-test, okay? Z-star is your test statistic. The next thing you're supposed to do is check your assumptions. So what's the assumption that we make or have to check? Is it normal? So are you given that the mean weight of women students is normal at the college? No. So because of that, we then have to take it a step further. Can we use the central limit theorem? Yes. So since n equals, how large is our sample? 100. Since n equals 100, and that is greater than 30, we can use the CLT. We abbreviate, and that's okay. That is a super commonly used term in statistics, so if you use that, everybody's going to know what you're talking about. You know, with some things they use different symbols. Sometimes they call it something different, like rejection region approach, critical region, classical approach. So depending on the textbook and the person, they might not know what you're talking about. But CLT, that is like so commonly used. Anybody should know that if they know stats. Okay. All right. So we can use the central limit theorem to assume normality. Very nice. So because it's normal, now I can run my test, right? So the first step after you check the assumption is to what? Good. State your hypotheses. So H sub O, H sub A. So we are testing mu, the mean, so I'm going to go ahead and put that in there. And then Professor Hart does not believe the claim. So the claim is that women weigh, on average, 54.4 kilograms. And he's trying to show that it's not. So he doesn't care if it's less than that or greater than that. He just wants to prove it's not that. So what would I put in my alternate? Not equal. Very good. Not equal. Okay? So because it's not equal to, this means it's going to be a two-tailed. Very good. So sometimes I write that right there, just so I'll remember, Okay, the next step after you state your hypotheses is to state your level of significance. Okay, that's called the level of significance, your alpha. And I gave it to you this time, so you're going to use 0.05. Remember what alpha is? What is alpha? What is the level of significance? Why do we use it? No, that's p-value. I like it though. She said it's the probability that. So I was like, okay, she knows it's probability. It's not confidence level. It goes with confidence level if we're 95% confident. Good. It's the probability of making a type 1 error. Okay? If your confidence interval is 95%, then your alpha, your probability of making a type 1 error would be 5% or 0.05. Okay? Typically, type 1 error is worse, so that's why we work with it. We emphasize it. Okay? All right, so we state our level of significance. So then our next step is to plug it in and calculate the test statistic. This is called the test statistic, okay? And that does change depending on whatever test we're using. So depending on our parameter of interest, all right? So we're going to use sample mean, which was 53.75 minus 54.4, the population mean, divided by 5.4, which is the population standard deviation, over the square root of our sample size, so 100. That's a really good sample size. And if it's a college, you should be able to get 100, right? Okay, so when you crunch those numbers, what do you get for your test statistic? Negative 1.20. So with the p-value approach from there, we would figure out what our actual p-value is using that test statistic on our chart, right? But for the classical approach or the rejection region approach, instead of using this, we will in a second, but instead of using that, instead we're going to draw our diagram. I'm going to go up here just so I don't have to keep extending the page. So we're going to draw a diagram. This one has two tails. So I'm going to create those two tails. And I have to split alpha evenly between those two tails. Instead of it all being in 1 on either side, it's in 2. So 0.05 divided by 2 is 0.025. And now that you know the probability, you can work backwards to find the critical values. Remember, it's called a critical value. It's the z that's associated with this probability. So when you look at your chart, I should have seen blue charts. When you look at your chart, what do you get for this critical value? Negative 1.96. Do you all agree? Yes? And then what would this one be? 1.96. That's right. They always have symmetry. They're always the same. That's what's nice about this curve. We will start talking about chi-squared. Chi-squared does not have a symmetrical distribution, so you cannot assume symmetry and do that. The F distribution does not either. So the only two that do are the Z distribution and the T distribution. So that is a nice fact. Okay? All right, so now that we know our test statistic is here, excuse me, this is the test statistic, Z star. This is the critical value, so I'm going to call those Z. I now use my test statistic, which was negative 1.2. So if the mean is 0, it's below, and does it fall in the rejection region, or does it fall in the fail to reject region? Fail to reject, that's right, because Z star was negative 1.2. So we are going to fail to reject the null. Make sure you put what? The null. Okay, you state your decision about the null. Then you state your conclusion about the alternate. And so that's what I was talking about before while y'all were working on it. Your conclusion has 3 parts, okay? The first part is there is or is not evidence. So there is or is not. There is not. We had to fail to reject it, right? So there is not, you can say significant or sufficient. Either one. So what do y'all like to say? Sufficient, okay. There is not sufficient evidence at the 0.05 level of significance. In this class, you can just put LOS. I know what that means. If you are presenting to someone, you would say level of significance. Okay. So there's not sufficient evidence at the 0.05 level of significance to show or to conclude, to show that and then what were we trying to show? What was in our alternate hypothesis? That the average weight of women in college is not 54.4 kilograms. When I grade these, I look for 3 parts in the conclusion. Okay, the first part is there is or is not sufficient evidence. That comes from your decision. Okay, so if there is sufficient evidence, it means you rejected the claim. If there is not, it means you failed to reject. The next part I look for is your level of significance, because that tells people how confident you are in your response and the probability that you made a type 1 error. Okay? And then the final piece that I look for is that last part where you restate using words whatever was in your alternate hypothesis. So it's called a 3-part conclusion. Those are the 3 parts I look for. All right? Now, if you state it a little bit differently, but the meaning is the same, it's fine. All right? Because we all kind of have our own thing that we like. Some of you like to say significant evidence or to conclude because you're making a conclusion. It's okay. Everybody good? So should you always write a conclusion? Absolutely. Okay? That's why I kept emphasizing all the steps to completing a hypothesis test. They're the same. The only thing that changes is your test statistic, what you should calculate, okay? And if you're finding the p-value versus if you're drawing the critical region or the rejection region, okay? Any questions? No? All right.